Okay, let's see if we can do video number 3. This is going to cover, looks like numbers 11 through 17. All right, number 11 says, given the following polynomial function, find the comprehensive graph and list all the x-intercepts. Comprehensive graph right here means you want to show all maximums, minimums, and x-intercepts on the screen. So you're going to put this on your Desmos, but when you do that, you're going to have to change your window settings. Now, since this is a multiple choice question, you can look at your options down here, and you could just change your settings to match these options and see which one gives you this graph up above. Or you can use your knowledge and work the other way and find, just move the screen around until you get one that's close to one of those 4 options. So you can practice on your own until your graph on Desmos matches the example for the given graph. Once you have your entire graph on your screen, your comprehensive graph, then you can go ahead and move on to the next part. It says, what are the x-intercepts? So remember, x-intercepts, we're going to use commas to separate answers. Again, this bottom line, you always want to read this carefully. So once you have your graph, you're just going to go into Desmos, and you're going to find x-intercepts, and it says the x-intercepts, so we're going to put the x coordinates of the x-intercepts. And you're going to list them with commas in between. All right, I think that's all we need on that one. Number 12, find the zeros of the function algebraically, or graphically. So you can work your algebra magic here, or you can put this on the graph. You can practice if you're going to do this graphically. You're going to want to make sure you get a comprehensive graph, which means you want to have the entire thing on your screen so you don't miss some of your answers. We're going to list them all here. We're going to use commas again to separate answers so that we don't get marked wrong for doing it. Or possibly, if we're going to do this algebraically, so if we're going to do it graphically, we're going to put it in Desmos, comprehensive graph. If you're going to do it algebraically, since we have 4 terms, my first choice would be factoring by grouping. Those numbers are pretty big though, so I think my preference would be the graphing. If the numbers were smaller, I probably would go ahead and do some factoring by grouping here. Your choice though. If you like factoring by grouping, you can do that. 13, we're going to start going backwards. 13 says use only algebra to find a cubic function with the given zeros, which means cubic means we have 3 factors, which means we're going to have 3 sets of parentheses. When in those 3 sets of parentheses, we're going to have an x minus, and an x minus. And then we're going to use these numbers over here, the roots that they gave us. We got the -1, we got the 2, and it doesn't matter which order you put these in. We got the -3. This is again kind of messy. Now we're going to put each of those in there. And notice you're going to multiply them out. Or the nerdy word is expand them. Oh, that was weird. Let's take that extra D off of there. We're going to expand. When we expand, I'm going to put that answer up in here. It looks to me like when you go into Math Excel, you've already got part of it given to you. So when you expand out, if you don't get this x squared minus 5x minus 6, you know you made a mistake somewhere. Go back and rework it. We're really just looking for what is going to go right here. So we've got an x cubed. We're going to have something, some number in front of this x squared term, and that's what you're going to enter. Again, read carefully, make sure you're putting it in the form they want. Same thing happens down on number 14. You're going to go x minus, x minus, x minus. You're going to take each of these x-intercepts that they give you. You're going to plug them in, and then you're going to expand very carefully. And it's going to be, this one's multiple choice, so you're going to find the one with the lowest degree. All right. Number 15, use a cubic regression. So I made a video on regression equations in Desmos. This one, when you go into Desmos, so we're going to use Desmos. This time you're going to do a cubic regression. So you're going to enter your data. And if you want to see it in action, go ahead and pull that video back up. It's still posted. And then when we put the formula in, it's going to be y1, excuse me. And then we're going to do the tilde. That's how Desmos knows to do a regression equation. And if we have a cubic function, we're going to have an ax1 cubed plus a bx1 squared plus a cx1 plus a d. Now those ones have to be with the y and with the x so that they match what's in your table. In your table at Desmos, you're going to have an x1 and a y1 in there. And then the computer should do the rest for you. Read the directions carefully here. And to make sure you put it in the form they want. It says integers or decimals on this one. All right, number 16. Determine whether the statement below is true or false. Justify your answer. Justify is getting to be a bigger and bigger word for us. So justify is your reason. So in the words down here, you're going to read the words carefully. Okay. So they gave us a function, and they're telling us these should be x-intercepts. Are they really x-intercepts? And how do you know? And that's going to be your justifier. Number 17. Which of these specified functions might have the given graph? This is looking like it goes 1, 2, 3 directions. So that should give us a power. Remember when you're finding, so this is third degree. Down here I have an x to the first. Oops, that's not supposed to be there. An x to the first and an x to the first. So I have an x times an x times an x. So I'm going to add up those exponents. It's going to give me an x cubed. So you're going to check the powers on your choices, or check the degree. the sum of all the powers. Remember, x really means x to the 1. This is just a star to help you remember here. All right, so you're going to use that and figure out which one of those formulas will match that graph. All right, that's it for 2.3.